Earth provides a perfectly balanced atmosphere and a protective magnetic shield. But relying on a single safe harbor carries a mathematical guarantee. Any species confined to one rock will eventually face extinction from a planetary catastrophe. Leaving that harbor introduces an immediate biological problem. Human bodies evolved specifically for a 1G environment, shielded from the sun. The surrounding universe is a lethal vacuum, saturated with ionizing radiation and extreme temperature swings. Conquering the cosmos requires a systematic overhaul of our infrastructure, our physics, and our own biology. The generations that eventually set foot on distant star systems will look, think, and operate very differently from the people walking Earth today. Modifying our biology and restructuring our societies is the mandatory, non-negotiable toll we must pay to ensure the long-term survival of our species. This photograph shows the stark, desolate surface of the moon. Between the 2030s and the end of the century, this landscape, along with Mars, will serve as our local testing ground. We have to master living in an absolute vacuum before we can aim further. And when we pan across this barren, rocky Martian landscape, the scale of required engineering becomes clear. The thin atmosphere and severe dust storms here mean colonists will need to either terraform the entire planet or build pressurized subterranean cities. Alternatively, we can bypass planets entirely. We can construct massive rotating space stations called O'Neill cylinders. These structures use centrifugal force to simulate gravity and hold artificial Earth-like climates inside. To build them, we need an independent space economy. Autonomous robots will extract water and metals directly from asteroids, while giant orbital solar farms gather uninterrupted energy. Constructing these self-contained habitats and supply chains cuts our reliance on Earth's materials. We learn to survive on our own in the vacuum of space. These insets show Alpha and Proxima Centauri, our nearest stellar neighbors. Once we can survive independently in our own solar system, the next barrier is reaching exoplanets in habitable zones, like Proxima b. Our current chemical rockets burn immense amounts of fuel just to escape Earth's gravity. To cross the light years to another star using that technology would take tens of thousands of years, far too slow for a human lifespan. We must shift toward nuclear propulsion, which offers a realistic way to achieve rapid interplanetary travel within our own solar system. This diagram compares the travel times of different propulsion concepts. To cross the massive interstellar distance line, we have to rely on complex theoretical technologies. We could use giant lasers to push ultra-thin light sails, or eventually develop antimatter and warp drives. Bending these rules of physics turns the uncrossable void of deep space from an impenetrable wall into a traversable highway. Even with perfect infrastructure and warp-speed engines, the psychological isolation and physical decay of deep space are too severe for unedited human bodies. To endure constant radiation and muscle atrophy caused by altered gravity, we must actively rewrite our biology through genetic modification. For environments that remain completely hostile to any biological life, colonization will require cyborg enhancements and the integration of post-human artificial intelligence. This physical separation leads directly to cultural drift. Colonies isolated by light years will rapidly diverge from Earth, evolving separate ethical frameworks and independent, decentralized governments. Navigating the cosmos becomes an evolutionary crucible. The pressures of space will permanently splinter the human species into diverse, highly specialized offshoots. Over thousands or millions of years, this expansion can be tracked using the Kardashev scale, a metric that classifies civilizations based on the total amount of energy they can harness. This animation illustrates a Type 2 civilization. At this stage, humanity constructs massive megastructures, like this Dyson sphere, to enclose a star and capture 100% of its energy output. Zooming out, that single enclosed star joins a web of millions. This represents a Type 3 civilization, where a species controls the energy and communication network of an entire galaxy. This staggering level of galactic expansion serves one core purpose. It is the ultimate, indestructible insurance policy against our own extinction. By the time we leave a galactic footprint, Earth will be a distant, ancient memory. We will have survived, but our descendants will look back on Earth as a cradle they outgrew, biologically, culturally, and physically.